Hello, welcome to this video on graphing cosecant and secant with period changes and phase shifts. I'm going to start off with your prior knowledge of cosecant and secant. I want you to remember that cosecant theta is equal to 1 over sine theta. So for prior knowledge here, if we ask what is cosecant of pi 4, well, sine of theta is root 2 over 2. So if we took that reciprocal, that would be, we would get 2 over root 2, which is just the square root of 2. Now, same thing, cosecant of theta, if I took the value of, cosecant of 0, if I took sine of 0 at 0, at sine, that value is 0. So 1 over 0, that's undefined, and visually you guys know that an undefined value is an asymptote. And last but not least, we have pi over 2. At pi over 2, your sine value, your y value is 1, so 1 over 1 is just 1. Okay, continuing along with this train of thought here, if we have secant theta, remember secant theta is 1 over cosine theta. So at pi thirds, you have a cosine value of 1/2, so 1 over 1/2, that is 2. For secant of pi, at that value, your x value, your cosine value is -1, so 1 over -1 gives you -1. And at 3 pi over 2, we get an undefined value for secant. Okay, so this is just some values maybe you want to jot down in your notes to help kind of develop this idea of how we're going to graph cosecant and secant in this lesson. This lesson is going to start off with cosecant of x, and below are shown the graphs of y equals sine of x and y equals cosine of x. What I really want you to focus on is the zeros of sine of x, and you should notice here, 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 and here, and here, that at sine of x, these zeros, when sine is 0, right, that gives, when sine is 0, that makes cosecant undefined, and there we have all of our vertical asymptotes. The other really critical points that you should notice is the maximums of sine of x, which occur at pi halves, and then also at 3 pi over 2, you have a minimum. These are the maximums for cosecant of x, and the minimums for cosecant of x, respective to sine of x. So those are just kind of the critical points and features that you should really notice. Now, developing cosecant of x, I want you guys to focus on a couple of things that are critical for drawing graphs, especially trigonometric functions, is that we have a period of 2 pi radians. So starting at 0, we have an asymptote, and we have this U shape. This is what cosecant of x looks like. And we have another asymptote at pi. So the period's 2 pi, it repeats itself every 2 pi, but you kind of have this split every pi, where one interval of pi you have like a U, and then the other kind of interval you have a downward facing U. Okay, so notice that the domain is x values, where x is not equal to pi times k, where k could be any integer. So notice just every single pi that there's an asymptote. Okay, you're not going to have a domain value to input there, and then the range is from -infinity to 1, or to -1, pardon me, and from 1 to positive infinity. We kind of have this empty space as far as outputs go. in this area. Okay, so the values of your graph are here for your parent functions. So you have these points at pi fourths. Square root of 2, that's approximately 1.4. So you have a value here. Okay, at pi over 2, you have 1, and this is the key points you'll want to remember, is that you have a maximum of 1, and here would be 1.4. And if I go on to the second portion of my first period, I have the same points, but they are negative. Okay, and again, the key points that you'll want to remember are pi halves, positive 1, and 3 pi over 2, negative 1. Okay, the positive interval comes first. So here is the general form for cosecant of x and secant of x, and I want you to notice we've spent the past couple of days graphing tangent and cotangent. Notice how the period's back to 2 pi. So we're going back to 2 pi. Tangent and cotangent are the two functions that go with pi, okay, as far as period. But cosecant and secant line up with our sine and cosine functions. Okay, we're also going to have a phase shift. So if we have a 1 over b value, which is going to change our period, and we also have a c value, then we'll have to divide c by 1 over b. Below here, these are the steps in your notes. If you want to read over these on your own, you can read those. I won't read those to you now. But these are the steps that we'll follow when we're graphing these functions. Okay, so here is the first video on graphing cosecant of x, and we're asked to identify the period and the phase shift, and then just sketch as much of the function as possible. So we're going to fill up the rest of the graph with all of our repeating cycles. So here we have y equals 2 cosecant of x plus pi over 4. The period is going to be 2 pi. Our 1 over b value, the coefficient, is just 1 here. Sorry, it's a pretty janky one. So 2 pi over 1, that gives us 2 pi. So our period's 2 pi, that's not going to be changed. And we have a phase shift here, okay, of negative pi fourths. So we're just going to shift back pi over 4. The other thing worth noting is that we have a value, okay, a is 2, so we're going to stretch, or we're going to multiply by a factor of 2. So let's go ahead and graph our function. So notice our scale's already laid out for us, and it should be that way too on your guided notes if you're in my class. And it goes every 4 units is pi, so that means every unit is pi fourths. So if I have to go backwards, oh no. Oh man, sorry, I had a glitch. I lost my annotations, so I'm just gonna re-edit this back here. So we have a period of 2 pi, phase shift of negative pi fourths with an a value that is 2. So graphing this, again, it's split into fourths by pi. So if I go back, this is going to be a vertical asymptote, and then I'll have another vertical asymptote at about pi units later. So the period is 2 pi. However, it's split into a upward facing U and then a downward facing U. So I'm going to add in the the asymptotes, and then I'm going to add in my points. Now, this is the great thing about secant and cosecant is you're just going to add in the one parent function point. So you're going to split the interval with your asymptotes, and you're going to draw your maximum point. So I'm going to draw a point halfway between, and normally my parent function point would be at 1. However, we have a value of 2. So I'm going to plot a point up here at 2, and we just kind of approach our asymptotes going up, looking almost like a parabola. So a U, there you have it. And I'm going to do the same thing down below. I have a point at -2, and I have a U. Okay, and that's it. Now we just have to repeat as much as possible, sketch as much of the function as possible. So it says here for this. So we'll repeat, and I'll save you the boringness of watching me repeat this, and I'll bring up the graph. So if you want to go ahead and copy down this example, and we have your points again at 2 and -2, and then they repeat out about every pi. Okay, so that is the example of cosecant of x. Here is a practice problem on cosecant of x. Please pause the video, try this on your own, and then take a glance back if you need help with period phase shift, and then I'll show the final answer after I give you a second to try it. Okay, so hopefully you've had a chance to try this. If you're looking at the period is going to be 2 pi. Your 1 over b value is 1, so that remains unchanged. And then we have a phase shift of pi halves. You're going to the right, and then you also have a value that is -1. So you're going to have reflection. Your maxes are going to become mids, and your mids are going to become maxes. Okay, so hopefully you've had a chance to graph the function. Here is the solution. Okay, so that's the video on cosecant of x. Hopefully you found it helpful, and I'm gonna pause this video, and I'll have a second video on cosecant of x.